Welcome to the deep dive. Today we're tackling a dinosaur that really makes you rethink the classics. Brachytrachelopan masai.
hmm
You picture a sauropod, you automatically think long neck,
Yeah.
right? Like Diplodocus, Brontosaurus,
Yeah,
this huge animal.
absolutely. That's the iconic image.
But Brachytrachelopan, it went completely the other way.
Yeah.
Its neck was, well, surprisingly short, shockingly short even.
It really was. And that's the puzzle we're diving into today, using the original scientific paper by Rahut and his colleagues from 2005 as our main guide. Plus some other bits to, round out the picture.
Yeah, our mission for you is to figure out why. Why did this one dinosaur buck that massive long neck trend? And what does its short neck tell us about how it lived, its world?
Exactly.
We want those aha moments for you without just burying you in dino facts. So, okay, let's jump in. Where and when did this oddball first turn up?
Right. So the story starts in Argentina, Chubut province specifically, which is in west central Patagonia.
Okay.
Patagonia. The fossils themselves came from rocks that used to be ancient riverbeds. Fluvial sandstone, we call it, part of the Cañadón Calcáreo Formation.
And when was this? What time period?
Late Jurassic. So think somewhere between roughly 163 and 145 million years ago. The paper mentions the Oxfordian to Tithonian epochs specifically.
Wow, okay. Late Jurassic Argentina and the actual discovery spot.
It was on a hill near a place called Cerro Condor, about 25 kilometers northeast of there.
And wasn't it found by a shepherd? That's such a great detail.
It is. Daniel Mesa, a local shepherd, was just, out doing his job and stumbled across these bones.
Incredible. Just goes to show discoveries can happen anywhere.
It really does. And his find became the holotype specimen. That's the main example used to define the species. It's cataloged as MPEF BV 1716.
MPEF PV 1716. Got it. How complete was it?
Not fully complete, unfortunately, but what they found was pretty good, and importantly, it was articulated.
Meaning the bones were still connected in their original positions.
Exactly. They found 8 neck vertebrae cervicals, 12 back vertebrae, or dorsals, and 3 sacrals, the hip vertebrae,
Okay.
plus bits of ribs, part of a femur, the thigh bone, the top of a tibia, the shin bone, and a piece of the ilium, which is part of the hip.
So a decent amount to work with, even if not the whole thing.
Definitely. Though the researchers did mention that, sadly, some bits had probably eroded away before Daniel Mesa found it, just lost to the elements.
Ah, that's a shame. Still, enough to give it a name. And the name Brachytrachelopan masai, that tells its own story, doesn't it?
It absolutely does. Brachytrachelopan literally means short-necked pan.
Pan, like the Greek god.
Yes, the god of shepherds. So it's a nod to Daniel Mesa's profession.
Ah, clever.
And then Mesai, the species name, directly honors Daniel Mesa himself.
That's fantastic. A really nice touch.
A great way to recognize the person who brought this really unique animal to light.
Short-necked pan. I mean, it hammers home the main feature. Just how short are we talking? Because like we said, sauropod equals long neck, usually.
Right, and that's what makes it stand out. Its neck was roughly 40% shorter than other dinosaurs in its close family, the Dicraeosauridae.
40%, that's significant.
Hugely significant. And when it was described, it was the shortest neck known for any sauropod. Full stop.
Wow.
So yeah, that immediately raised the big question, why? Why so different? It forces you to see that not all sauropods were these giants reaching for the treetops. Brachytrachelopan suggests a whole different strategy.
Focus more on the ground level, maybe?
That's the idea, focused on resources down low.
Now, the obvious first thought might be, okay, maybe it's just a baby, a juvenile of a species that would have grown a long neck later.
A very reasonable thought. But Rauhut and the team looked closely at that.
Yeah.
They pointed out that the vertebrae, both in the neck and the hips, showed a high degree of fusion between their different parts.
Fusion, meaning the bones had finished growing together.
Exactly. That kind of extensive fusion is a hallmark of a mature adult animal, not a youngster.
So definitely an adult.
Yeah.
An adult with a genuinely, permanently short neck.
Precisely. This wasn't an awkward teenage phase. This was its final form. And that's where it gets, anatomically really interesting.
Because it wasn't just the length.
Right.
There were other weird things about the bones themselves.
Yes, exactly. The 2005 paper lists several distinct features, autapomorphies we call them, that define Brachytrachelopan.
Okay, like what?
Well, first, those neck vertebrae, the cervicals, their length front to back was the same as, or even shorter than, their height at the back end.
Shorter than they were tall. That seems compressed.
Oh,
Very different from the long spool-like vertebrae you often see.
Very different. Then there's this bony ridge, a lamina, connecting parts of the vertebrae. It's called the centroposicopophyseal lamina.
Okay.
In Brachytrachelopan's neck vertebrae, this lamina was really pronounced almost like a pillar. Very distinct.
A pillar-like structure. And what else?
The neural spines, those are the projections sticking up from the top of the vertebrae. In the middle part of the neck, these spines tilted strongly forward.
Oh.
So much that their tips actually stuck out further forward than the front edge of the main body of the vertebra below.
Wow. That sounds like it would affect how it could move its neck.
Very likely, yes. Probably limited upward flexibility quite a bit. We'll come back to that.
Okay. And there was something about the back vertebrae, too.
Yeah, the neural spines on the first 6 back vertebrae, the anterior dorsals, their bases were pretty much vertical, but then the tips bent forward, kind of flexed anteriorly.
So lots of specific, unique details in the bones. Not just a shorter version of a standard sauropod neck.
Not at all. These details are key clues to figuring out how it functioned.
Right. So let's place it in the family tree. Where does this short-necked wonder fit in the grand scheme of dinosaurs? Classification time.
Okay, big picture first. Domain Eukaryota, kingdom Animalia, phylum Chordata, then down into clade Dinosauria.
The main dinosaur group.
Yep. Within that, it's a Saurischian, one of the lizard-hipped dinosaurs.
Yeah.
Then Sauropodomorpha, which includes all the long-necked herbivores and their relatives.
And the Sauropoda proper.
Right. And within Sauropoda, it's in the superfamily Diplodocoidea, so related to things like Diplodocus and Apatosaurus, but more distantly. And then specifically the family Dicraeosauridae.
Dicraeosauridae. Okay, we mentioned its neck was short, even for that family. Who else is in that group? And what did the original researchers say about its closest relatives?
So the Dicraeosauridae are known for generally having shorter necks than other sauropods, and often tall neural spines. Rahut and colleagues did a cladistic analysis that's a method to reconstruct evolutionary relationships based on shared features.
Like building a family tree.
Essentially, yes. Their analysis suggested that Brachytrachelopan's closest relative was actually Dicraeosaurus.
Dicraeosaurus, wasn't that found in Africa?
That's right, from Tendaguru, Tanzania, also late Jurassic.
Huh. So a South American dinosaur most closely related to an African one.
Yeah.
Even more so than other South American Dicraeosaurs.
That's what their analysis indicated. They found it was closer to the African Dicraeosaurus than to Amargasaurus, another famous Dicraeosaurid from South America, but one that lived much later in the early Cretaceous.
That's really interesting, especially thinking about geology. The continents were moving around back then.
Precisely. That's a major implication Rahut and the team discussed. They saw this Brachytrachelopan, South America, Dicraeosaurus, Africa, link as evidence for a quick evolutionary diversification and spread of the Dicraeosauridae after Gondwana, the southern supercontinent, had started breaking up and separating from the northern continents in the late Middle Jurassic.
So its family history is tied up with continental drift.
Directly. It suggests these dinosaurs spread across Gondwana before Africa and South America fully separated, or perhaps there were still connections allowing movement.
Has that picture changed at all since 2005? You mentioned a newer study.
Yeah, there have been more analyses. A significant one by Tshop and colleagues in 2015 refined the Dicraeosauridae family tree a bit.
How does Brachytrachelopan fit in their view?
In their cladogram, Dislochosaurus is the most basal, the earliest branch. Then you get a little group with Suwasi and Dystrophaeus. After that comes Brachytrachelopan.
Okay.
And then you get the tightest pairing between Amargasaurus and Dicraeosaurus. So Chop's analysis puts Amargasaurus and Dicraeosaurus closer together than Rahut did, with Brachytrachelopan branching off just before them.
So still clearly a Dicraeosaurid, but the exact branching order within the family gets tweaked as we find more fossils and refine analyses.
Exactly. Science marches on, but its position as this distinct short-necked member holds firm.
Okay, so we have the what, the where, the when, the who. But we keep coming back to the why. Why the short neck? What was the evolutionary payoff?
Right, the paleoecology, how did it actually live? This is where Rahut et al.'s main hypothesis comes in. They proposed that the short neck was specifically an adaptation for low browsing.
Feeding low to the ground.
Yeah, feeding on plants growing, say, between about 1 and 2 meters high, maybe even lower.
Which is just so counterintuitive for a sauropod. We always imagine them reaching high.
Totally. And this trend towards shorter necks within the Dicraeosauridae family, with Brachytrachelopan being the most extreme example known at the time, is the complete opposite of what you see in most other big sauropod groups, like Brachiosaurids, Titanosaurs, Diplodocids. They were all generally going for longer necks.
So the Dicraeosaurids were carving out a totally different niche.
It really looks that way, a different way of making a living as a giant herbivore.
And those anatomical features we talked about, the forward tilting spines, the shorter vertebrae, how do they support the low browsing idea?
Well, that specific anatomy, especially the orientation of the joints between the neck vertebrae and those forward tilted spines, probably restricted how far it could bend its neck upwards.
Ah, so it wasn't just short, it was maybe physically difficult for it to lift its head very high.
That seems likely. The structure reinforces the idea of specializing on food sources closer to the ground. It physically couldn't browse high even if it wanted to.
Maybe a trade-off then. Less reach, but maybe more strength or stability for foraging down low.
That's a plausible way to think about it, yeah. And the researchers also floated the idea that this specialized low-browsing diet might have actually limited the overall size these dinosaurs could reach.
How so?
Well, if you're only eating lower-growing plants, maybe there's just less total food available, or maybe it's less nutritious compared to browsing high in the canopy. That could constrain how massive you can afford to get.
Makes sense. Do we have an estimate of its size?
Gregory Paul in 2016 estimated its body mass around maybe 3 to 5 short tons, which sounds big to us, but for a sauropod, that's relatively small.
Right, compared to the real giants. Okay, and you mentioned something fascinating before, this idea of an ecological analog. That Brachytrachelopan might have been doing a job similar to another group of dinosaurs.
Yes, this is a really cool concept. Rahut and his team suggested that Brachytrachelopan and its dicraeosaurid relatives might have occupied a similar ecological role to the large iguanodontian ornithopods.
Iguanodontians, those are the ones with the thumb spikes, right? Big plant eaters, but not sauropods.
Exactly. Two-legged or four-legged stance, definitely herbivores. And the interesting thing is their distribution.
How so?
Large iguanodontians are basically missing from the late Jurassic rocks in Gondwana, South America, Africa, etc., precisely where we find all the dicraeosaurids like Brachytrachelopan.
Okay.
Flip over to North America during the same period, the late Jurassic. Large iguanodontians are common, they're abundant there. And guess what's missing in North America?
Dicraeosaurids.
You got it. Completely absent.
Wow, so it's like the two groups were doing similar jobs, eating similar low-growing plants, but in different parts of the world where the other group wasn't present.
That's the inference, and it's a strong case for parallel or convergent evolution. Nature found a similar solution, the large, low-browsing herbivore niche, but filled it with different types of dinosaurs on different continents. The absence of competition from iguanodontians in Gondwana might have opened the door for dicraeosaurids to specialize in that way.
That is fascinating. So Brachytrachelopan wasn't just weird, it was potentially Gondwana's answer to the iguanodont.
In a manner of speaking, yes. It occupied that large, medium-height browser niche in its ecosystem.
Okay, let's try and wrap this up. We've got Brachytrachelopan in Late Jurassic, Argentina. Discovered by a shepherd, named in his honor. Its defining feature, that incredibly short neck for a sauropod, maybe 40% shorter than its relatives. And it wasn't a juvenile. Bone fusion proves it was an adult.
Right. With unique vertebral features, short length, pillar-like structures, forward-tilting spines that likely restricted upward movement.
All pointing towards a specialized lifestyle of browsing on low-growing vegetation, maybe 1 to 2 meters off the ground.
A stark contrast to most other sauropods, suggesting dicraeosaurids took a different evolutionary path.
And its relationships, especially the connection to the African Dicraeosaurus, hint at dinosaur dispersal across Gondwana as the continents were shifting.
Plus that intriguing idea of ecological replacement, filling a niche occupied by iguanodontians elsewhere.
So the big takeaway, the aha moment, is that this seemingly disadvantageous short neck was actually a key specialization, an evolutionary advantage for Brachytrachelopan's specific way of life in its particular environment.
Precisely. It's a fantastic reminder that evolution doesn't always go in the direction we expect. Sometimes doing the opposite of everyone else is the key to success.
It really makes you think, doesn't it? When you look at the natural world, how many other features that seem strange or counterintuitive at first glance might actually be revealing these incredibly specialized lifestyles and evolutionary stories if we just, dive a little deeper?
Absolutely. The exceptions often tell us the most interesting tales.
Food for thought. Well, thanks for joining us on this exploration of the short-necked pan. Until our next deep dive.